Okay, so in the past, when you are executing some programs, I'm sure you must have come across exceptions. So you basically didn't know what that is called. That's it. So exception is nothing but an error that is basically abrupting the flow of the execution of the program. So this is like, this usually has a traceback, that is an error message that gives information regarding what the error is and what caused that sort of exception. So let's let's talk a little bit more about exceptions, and then I'll show you an example as well. So basically, when you're trying to introduce the input validation loops, you are eliminating the most common errors that you can expect. So input validation loops can eliminate the exceptions, like many of the exceptions, but some exceptions cannot be avoided even by using some careful coding techniques. Like, for example, when you're trying to convert a non-numeric string into an integer, when you're trying to open a file for reading that doesn't exist. So in that cases, you will be looking at exceptions, that is file not found error in the second case. When you're trying to convert the non-numeric string to an integer, you will be looking at the type error, that is when you're trying to do anything with two different data types. So exception, the basic definition is an error that occurs when a program is running. Like basically it's a runtime error and it is causing the program to abruptly halt. And Python raises exceptions. So the term raises is also important. So we can always call, like, then error is thrown or error is being raised. So Python raises exceptions and it prints a trace back with a little description about the error as well. So when you look at this example here, I'm defining the main, I'm getting the two numbers, int input, enter a number, int input, enter a number, and I'm performing the division and I'm printing the result. That's it. This is just simple program. But the user has entered the first number as 10 and the second number as 0. So you're basically trying to divide a number by 0. The output is infinite and the program cannot display it infinite. So that's the reason why it is giving you an error, that is 0 division error. And this is called as traceback. So this is basically tracing back to the location where the error has been caused. So it will show you that line 13 in module, like that is the main module. Inside the main module, the particular error is at line 9. So result num1 by num2. So when the problem is at num2, as you are trying to divide num1 by 0, as the result cannot handle infinite, that is the reason why you are saying this error or exception, which is 0 division exception. So there are multiple sorts of exceptions. We can have name error when you are trying to use a variable that has not been defined in prior to the usage of that variable, then you will see name error. Value error is when you are trying to perform two different operations, but you're expecting one thing, but you're looking at a different thing. So you will be getting value error. Zero division error, that is by dividing 0. Overflow when you are trying to include more contents than it can take. Type error when you are trying to perform any mathematical operations in between two different data types. And IO error, that is for input output when you're trying to create a file or when you're trying to rewrite the contents of a file with your different settings, then it is called, you can see an IO error as well. So let's see. Okay, this is not supposed to be here because I have not discussed try and except just yet. So I'll just move on to the next slide. We can always use if else blocks to eliminate the possibility of exceptions. So here in this case, I'm just having if num2 is not equal to 0. So if the second variable is not equal to 0, then only then you're performing the result, like the division operation, and then printing the operation. Else you're just saying cannot divide by 0. So instead of abruptly halting the program, you are just displaying the message that says cannot divide by 0 instead of getting a 0 division error exception. So that is one way to handle exceptions. It is important to handle exceptions, and even though you have handled some of the exceptions, there can still be cases where you see exceptions. Like, for example, in this case, you have hours, you're asking the users the number of hours, pay rate, and then calculating the gross pay, and then you're printing the gross pay. So here, instead of entering numerical data, the user has somehow thought it is to enter as alphabetical. So it is FOURTY40 instead of 4040. So according to the user had it right. But according to our program, it is not right because we are expecting an integer or numerical data and we got string data. So that is the reason why you see value error, that is invalid literal for int with base 10 40. So this is an example of, there can still be some of the exceptions. But when you want to handle such unexpected exceptions, we can use the try and except block. So this works like if else, but instead we are just going to use the different keyword names, that is try and except. So the general format will be try, statements, except, exception name, statements. So except exception name will eliminate the possibility, like, instead of throwing a trace back or instead of raising a exception, it will just print the statements underneath that exception. So we'll see how that looks like. So the try suite will basically have, or the try block will basically have all the operations like, division, or if you're performing any mathematical operations, all that operational stuff is always inside the try block. And except block, which is also called as the handler, will only handle any possible cases of exceptions. So we'll see from this program here. So we are using the same program, ours, pay rate, gross pay, and then you are displaying the gross pay. So this is basically the heart of the program, or basically the main part of the program. So the main part of the program is inside the try block, and in the except block, we are expecting a value error from the previous example, FOURTY. So that's the reason why I'm just having except value error, print error, hours and hourly pay rate must be valid integers. I can just say that. So instead of abruptly halting the program and instead of throwing, like, raising the red block like this, now if the user enters FOURTY, the user will only see this: hours worked and hourly pay rate must be valid integers. So instead of abruptly halting the program, you are just going to say this. So the structure of the program or working of a try and except block is, if the hours and pay rate and are regular integers, and like, integers for hours and floating point for pay rate, there is no problem with the gross pay. You are just going to execute the try block, and then the except block will be skipped. You are not going to execute the except block, and then you are going to move on to the rest of the program. If there is an error in the try block, then from that error, it will jump to the except block and it will execute the statements in that except block. So here we do know that it is, the user has entered, let's say, FOURTY 40. So from here, from the hours line 1, it will jump to the except block, and then it will print hours worked and hourly pay rate must be valid integers. So I've discussed this. So if there is no exception, then handlers are skipped. So here is another example: file name, input a file name, reading in R, and the file name, you're trying to print the contents. So you're using the read method, print contents, close. So as you're using the read method, you are assuming that file name should already be existing on your computer. If that is not existing, it will just throw an exception, that is file not found error. So it also points to hey.txt is not existing on your computer. Now you can handle that by using the try and except block like this. So in file, contents, print contents, file close. Except IO error, an error occurred trying to read the file name. So as it is an input output error, you are accepting an IO error. Or you can always use the file not found error as well, like except file not found error, print these two statements. So if the user has entered a file name that is not existing in the computer, instead of throwing an exception, it is now printing the statements under this particular exception. So you can also use nested try. So basically nested try is same as the nested if the statement, if the block is already having an if else block, then it is called as nested if. So if the try block is already having a try and except block, then you will be seeing the nested try. And also you should understand that for every try there is at least one except. So you can have one try and have 3 to 4 accepts. That's also fine. But you cannot have one try and no accepts. So try and accept are like a pair. So if you are using try, you must use an accept as well. So try num integer, like enter the numerator, enter the denominator, and inside the first try, you are having another try, that is result, numerator by denominator, print the result, except print divide by 0 error. So if the error is here, then you are going to divide by 0 error, except invalid input, print end of program. So in this case, the user has entered 10 to 5, end of program. So there is no error here. So result has been performed and you are printing the result. This 2 except blocks have been skipped. Next, you have just printing end of program. But in this case, the user has entered 10 and 0. So we are performing the result and you have an exception here that you have an error here. So you will be printing divide by 0 error. So this except block is skipped because you are facing an exception inside the inner block, that is inside the inner try and except block. So often code in the try code can throw more than one type of exceptions, and we can, like, you can have multiple exceptions, as I've mentioned before. And you may not know all the types of possible exceptions that a program can have. So instead of having except value error, except name not found error, or except IO error, you can just have one except and then use the original message as an output for the user. So we'll see the example of that as well. And in the except clause, you can also use, like, except value error as ERR. So instead of you typing the message that is, both the numbers must be integers, it will just print the original message associated with the value error. So we'll see how that looks like. Okay, so here I have one try block and 2 except blocks. That's also fine. So print A by B, this won't be printed. Print 10 plus 10. Type error, the added values are incompatible. That is for the second statement, except 0 division error, you are dividing it by 0. So A value is 1, B value is 0. So when you are trying to print A by B, that will not be performed. So that was, you are going to see the error you divided by 0. So after the other 2 statements in the print block are not executed anyways, because you find the error here, you are jumping to the 0 division error and then you are printing you divided by 0. And when you are just using the except IO error, except value error, except an error occurred, you can, like, this is the same example, like with multiple exceptions, but in the last case, you are using except an error occurred. So if you are not sure if there are any more possibilities of exceptions, you can just say except an error occurred. And in this case, I don't see, do I have? Yeah. So this is the case where I'm not entering, like, improper data. Okay, so here I'm trying to open the file sales.txt. If that file is not present, then it is going to say an error occurred to open the file. And if I'm trying to add that string data and I'm trying to convert that into a floating point number, and as the data is non-numerical, then I can see a value error, non-numerical data has been found in the file. Like for example, this 45. Same thing, if I don't want to specify the name error or value error or IO error in this case, I can just use except an error occurred. So whatever the problem is, even if I have 45, instead of having value error, I'm just showing an error occurred. This is not a good way, like, this is not a good practice, because when the user is working on this, it is really difficult for the user to understand what the error is. It may be really difficult. So in that case, like, it's better to use this, or it is much better to use exception itself as ERR. So when you are using exception as ERR, and the same thing, like you have 45 in the file, when the file is trying to read this 45 and convert that into a floating point, as this cannot be done, instead of showing an error, that is, instead of showing a message that is an error occurred, it is now showing the original message associated with this exception, with whatever the exception is. So the exception in this case is type error. So it is showing could not convert string to float 45. Now, when the user is looking at this, the user may understand that there is something called 45 in the file, which is causing the issue. So accept exception as ERR, print ERR. That is also a good method. So if you want to just display the error message as the original, like the one that we have looked into just now, so you can always use accept value error as ERR. So here it was just accept any exception and its original message. But if you want to guess the possible exception, then accept value error as ERR, print ERR. That will also solve the issue. Now for the else clause, okay, we have already discussed this. I don't know why that. Okay, so there is this else clause, which is also associated with the try and except block. So the syntax is similar to the decision structure. So it's basically try except else. So the syntax will be like, the working will be like this. So first the try block will be executed. If there is an error in the try block, then it will move to that exception. So if there is an error in the try block somewhere, then it will move to the exception, that is except block, and it will print the statements underneath the except block. That is when there is an error in the try block. If there is no error, or if there are no exceptions raised in the try block, instead of executing except block will be skipped. The else block will be executed, and then you reach the end of program. So try block has no exceptions, except block will be skipped, and else block will be executed. If try block has exceptions, except block will be executed, else block will be skipped. So this is also a different example for the same. So you have except exception as ERR, else total. So in the first snip here, there are only numerical data. So there is no error, that is no exception that has been raised in the try block. So that means the except block is not executed, but the else block is executed. That's the reason why you see the output. In the second snip, which 45, an exception has been raised here. So except exception block is executed, else block will be skipped. That's the reason why you see the original message associated with that exception here. So that is for try except else blocks. Now we also have the finally clause. So basically the finally will execute no matter what happens with the rest of the program. So basically, like, end of program, or now you have reached the end of the file, sort of statements can be included in the finally suite. So you have try except finally, or try except else finally. So we do know the working of try and except. If there is an exception in the try block, except block will be executed, followed by finally block will be executed as well. If there is no exception in the try block, except block will be skipped, finally block will be executed. Now let's see the working of try except else finally. So try block, if there is an exception, except block will be executed, else block will be skipped, finally block will be executed. If there are no exceptions in the try block, then except block will be skipped, else block will be executed, finally block will be executed. So could not convert with 45, that is with snip 2, we have an exception. So exception as error, so except block has been executed. Next, finally, code without else block is also the statement underneath the finally, so that is also being printed. With the original slip without any numerical data, as there are no exceptions, except block is skipped, finally block is executed. Same thing with the else block. If there is an exception here, except is executed, else is not executed, finally is executed. That is here in this case, right here. If there is no exception here, except block will be skipped, else block will be executed, finally block will be executed. That is here. So there can still be some cases where exceptions are not handled. That is when you are not specifying the correct type of exception, and when the exception is raised outside the try block. So what happens if it is raised somewhere else in the program and not in the try block? So in both the cases, the program will be abruptly halted and you will be again seeing the error. So that is the basic concept of exceptions and how to use exceptions and what are the types of clauses and suits that are there when you are using exceptions. So that is the end of chapter 6. So the next thing that you'll be looking at is lab for chapter 6, and then the programming assignments for chapter 5 and chapter 6, which is your take home. So there will be no recording for programming assignments, like as there were no recordings for the past programming assignments as well. Okay. I'll see you in the next video.